Before I get started, I'm going to scroll through really quick. For people who don't have access to my OneNote, you can just watch the video and pause it to take a look at anything. Once I'm done scrolling through, we'll go ahead and I'm going to go through this example pretty quickly. Remember that there are other videos that talk about specifics such as data types or how to hook up different types of components and all those things. This is really just to talk about the example. Now, the other thing is example 1 is going to correlate with homework 1. And so if you go through homework 1 is going to deal with things like LEDs. In this case, 2 LEDs or 3 LEDs, and the example, we're really only going to be talking about a single LED. So I guess the main thing that I want to cover before we start is there are going to be a couple built-in functions that we're going to use. Functions are going to be blocks of code that are already written that all we have to do is we just have to call upon them to work. It's one line that we have to write, and it's going to be able to make our coding much, much easier because we don't have to necessarily do as much work later. The Arduino already has a whole bunch of code pre-written. The 3 functions that are built in that we're going to use in this example are pin mode, digital write, and our delay functions. All right, we're going to go ahead. We'll set up our LED here in a second. Actually, I think I already have it set up, but we'll talk about that. The example problem is we're going to set up a circuit with 1 LED. We're going to write a code that blinks that LED forever, and by forever we mean for as long as the Arduino has power. And then we're going to make sure that we're using variables. We're going to use a variable for the position of our LED. That's going to be a global variable. And we're going to use a variable for our delay time. That's going to be a local variable. Our circuit's going to be set up something like this. Now, it doesn't have to be exactly like this because it's your circuit and you can set it up. So as long as it is a correct circuit for a single LED, that's perfectly fine. But the things that need to happen is we have to have a complete circuit. We can see here no matter where we start, if we start up here at the 13, we travel all the way down. We're connected to this column on the breadboard, which is connected to the positive side of our LED. Our LED has a positive and negative side like a battery. If we go up and down our LED, we're on our negative side of our LED. And on that negative side, we have our resistor. This is a 330 ohm resistor, and that is connected to this line right here, which is connected to this black wire, which goes back to ground. So I have this circuit that goes completely around unbreakable. The next thing we want to do is we want to do a little bit of planning. So as far as the planning goes, I did a simple top-down design, and we could think about this maybe in a different way. Let's say that you're in your room right now, and I say, I want you to flash the lights on and off. And I want you to kind of organize how you're going to get that to happen. Well, number one, you have to be able to get to the light switch and get ready to do that, put your hand on the light switch and everything. And then the second thing we're going to do is we're going to have to blink it. So getting ready and everything, we can figure out how to do that. The blink portion, we have to be able to figure out how to turn on and off the switch. And we're going to have to figure out how to wait for a certain amount of time. So the Arduino is no different. I have to get something to get everything ready. You wouldn't have known that ahead of time. So I put this over here. It's make a pin and output. We'll talk about what that is a little bit more in just a second. And then to blink, we have to be able to send voltage. 2 ways to do that. We either do send it, turn it on, or we stop sending it, we turn it off. And we have to be able to wait. I'm going to take these 4 things, the 4 very bottom parts of our top-down design, and what I'm going to do is I'm going to put them in a flow chart. the very first thing I'm going to do is I'm going to set our pin as an output. That again is like getting up, standing next to your light switch. It's getting everything ready. I only have to do that once. And then I'm going to forever loop around and do something. So I have this sequence inside of here of things that have to happen, but I put that sequence inside of a repetition structure, something that's going to happen forever and always. That is, turn something on, wait, turn it off, and wait. And that's how we get our blinking to happen. And since it's repeating, then it blinks forever. In Arduino, there's something that we always have to have. We have to have this void setup section, and that happens one time, and it happens at the beginning when our code first starts running. And then I have this void loop section, which is going to run forever afterwards, and it's just going to keep looping it around and around and around. So I think that that's a good spot for us to hop over and to take a look at what we have. So I have here, I have our circuit. Circuit looks pretty similar to what I had in the OneNote. Things are plugged in at a little bit different spot, but I still have a circuit. Come up through the positive side, down through the negative, through the resistor, through the negative side, and back to ground. You'll also see that I have the required stuff in here. I have the void set up with parentheses, followed by an opening and closing brace or curly bracket, and the same thing with the void loop. These have to be in here, otherwise I get errors. Remember, this void setup runs one time, that's just getting things ready. The void loop runs after that, and it continues to run over and over. So if we were to want to flash the light in your room, you would only have to go stand next to the light switch once, and you do that at the very beginning. So up here is where I'm going to say that we need to go get everything ready. Now, the way to do this with Arduino is I'm going to put some comments in. That's what these 2 forward slashes are. That means it's just for me or for you or for another human being to see what I'm doing, but the actual Arduino isn't going to look at them at all. It's strictly a comment to help us to see what's happening. And here what I'm going to do is I'm going to set pin, and this LED is connected to pin 8. So I'm going to set pin 8 as an output. Now what that means is I have these digital pins up here, digital 2, digital 1, digital 0, digital 8. That's what D8 means. And the digital pins can either be inputs or outputs. Inputs mean I can send voltage into the Arduino. We're not going to talk about that today. Instead, today we're going to be saying that we can send voltage out. And that's how we turn on this LED, is I send voltage out to this LED. So I want to set pin 8 as an output. I have to tell it whether it's going to output or input things. Only need that to happen once, and so I put it up here in the void setup. Everything else I need to happen over and over again, I'm going to put here in the loop. All right, so the first thing I want to do is I want to turn on pin 8. Once it's on, right, we turn the light switch up, turn it on. Next, we're going to wait for 1 second. Next thing we're going to do is we're going to turn off pin 8. And then we have to wait again. We'll do for 1 second again once we get this written out. But what I've done right now is I've just thought through the process. I've done the designing, I've thought through the process, everything that has to happen, but I haven't had to actually think about how to program it yet. I haven't had to change my mindset from figuring out the process to figuring out how to actually code. And this is a nice thing to do when you're first getting started, is try to break those things up a little bit. And so that's what we did here with our pseudocode. All right, so now we have to look at line 3 here. So here's our line 3. I need to figure out what code do I use to set my pin 8 as an output. And this is a built-in function. It's something that's already written. We just need to know how to use it. What we're going to do is we're going to write out pin mode, all one word, but the M is capitalized. I'm going to have some parentheses with a semicolon at the end of it. But inside the parentheses, I'm going to be able to put information into it. Very similar to if I have a, in math class, if I have a function f of x, and I say that that is x plus 5, what happens if I write f of 3? We input this 3 into the function f of x, right? We put a 3 into here. This is going to be the same thing. I have these parentheses here, but I get to choose certain inputs to control how this pin mode works. It has 2 inputs that I have to use. The first one is, what position am I in? What pin are we using? And we're looking at this LED, which is connected to pin 8. So I'm going to put an 8 in here. I'm going to put a comma because this is how I separate my inputs. And the second thing I'm going to do is all capital. I'm going to write the word output. And what that does is that just says that it's going to turn pin 8 into an output. It's going to allow pin 8 to send voltage out of it. That's it. So I'm all set up here. I'm going to go ahead and keep my comments in here, my pseudocode in here, just in case you have to look at this, tomorrow or next week, or if somebody else takes a look at it, they know exactly what that line's doing, right? This is the computer version. This is the Arduino version of what's happening. This is human version, right? I can just read it very easily and I can know what's happening. I'm going to do the same thing. I'm going to jump down here to line 8, and I already know what's going to happen. I have these 4 steps. I just have to figure out how exactly I'm going to turn that into code. To turn on a pin, there is another built-in function, one line that I can type things into and I can control things. This function is called digital write. Again, it's all one word, and the W in write is going to be capitalized. I'm going to have a set of parentheses here, and I'm going to put 2 things in it again. Number 1, again, is going to be the location. Which pin are we going to be controlling? I'm going to be controlling pin 8. Separate with a comma. The next thing I'm going to do is I need to tell it whether it's sending voltage or whether it's not sending voltage, whether it's on or whether it's off. And the key word for that in Arduino is high or low. In this case, if I want to turn it on, I'm going to all capitalize, type the word high, hit the wrong button there. All right, there we go, high. I'm going to do the last parenthesis there, and I'm going to do a semicolon again. Semicolons are going to happen all the time when we type code out. The semicolon just means that we're done. That line is finished, we can move on, that task is complete. And so on line 8, our task was to turn on pin 8, digital write, 8, high. That's how you turn it on. On line 9, how do we wait for 1 second? Our last function that we need to talk about is our delay function. It is simply the word delay, all lowercase. And inside of the parentheses, I write how many milliseconds I want to delay. 1 second is 1,000 milliseconds. I finish up the line with the parenthesis and semicolon. And what's going to happen is when it gets to line 8, it's going to turn on this LED, and that happens practically instantaneously. Computers, microcontrollers, they all work very fast. And when it gets to line 8, it's just going to sit at line, or sorry, when it gets to line 9, it's just going to sit there for 1,000 milliseconds. That's so that we can actually see it turn on, and then it stays on for 1 second. All right, lines 10 and 11 are going to be very similar to lines 8 and 9. You might want to think about it for a second. What would you do to turn off pin 8 and then wait for 1 more second? Digital write, 8, low. That turns it off. And on line 11, delay 1,000. Don't forget your semicolons. All right, I'm going to go ahead and hit start to see if it's working. All right, so we have it flashing. Now, if you were to hit start simulation, if you were to be building this yourself and you get an error, this won't upload. Let me get a quick error in here. Let's say I forget a semicolon. You'll see that it won't even upload. It'll highlight some stuff, and down here it'll try to help you figure out what's going on. This one says that it expects a semicolon before the closing brace or curly bracket. So I'll go down here. Here's my closing curly bracket. It says it expects a semicolon. There we go. The other thing that might happen is maybe nothing's flashing. That means that the circuit's probably wrong. So the circuit could be wrong, the code could be wrong, maybe both are wrong. But if it's working, then that means both are correct. So that's a pretty straightforward thing so far. We have just a few lines of code, but in the example, there were a couple extra things that I said we wanted to do. I want to use variables for the LED position and the delay time. Now, I do want to remind you one more time, there are plenty of other videos out here that I've put together. There's other things online that tell you how to do certain things. I have a video about LEDs and how to connect them. I have videos on what a circuit is. I have a video on what these scopes are. I have videos on a whole bunch of different things. So what we want to do is I want to write a couple things in here, and there are some additional videos on it. There is a video on data types. So data types are going to tell us something about what can be saved in memory. And if you want to go more deep into that, there is videos on that. We'll talk about that in class as well. What I'm going to do is I'm going to make a global variable. That means that it is not inside of any other scope. It's not inside of any block of code. It's completely outside of everything. So I'm going to put that at the very top here on line 1. I'm going to make a variable that is a byte type, the data type. A byte can hold whole numbers between 0 and 255. And I'm going to call this variable LED. So first I say, what type of variable is it? Byte means it's a whole number between 0 and 255. LED is going to be the name. And then I'm going to give it a value. What I want to do is I want to get the position in here. And the position is going to be digital pin 8. And so now what I want to do is I have this global variable. Global variable means that it can work anywhere. I no longer need to have an 8 right here. Now what I can do in my code is I can just type the word LED anywhere I want an 8. So now when I do pin mode, LED output, what it really is saying is, well, whatever LED has in it is going to do that. So this is still LED or pin mode 8 output. What's nice about this is if I decide to change this, such as plug it into digital pin 5, I don't have to go through my whole code and find stuff. I can just go to the very top here and change that to a 5. And now we see that it's blinking. If I would have left it as an 8, it is sending voltage and stop sending voltage to pin 8, but we just don't see anything because it's empty. Nothing's happening there. So that is our first variable. I also want a local variable for the time for this 1000. Now I had to make a global variable for my LED because I was using it multiple places. I had it in the void setup. I have my LED here. I also have it in my loop right here. So I had it in multiple spots. I needed it to be a global variable. With this 1000, I'm not using that up here in my void setup. I'm only using the 1000 in the void loop. And so I can make a local variable. I'm going to make a spot above where I use it. So I'm using it for the first time on line 13. So on line 10, above that, I'm going to make a variable to hold that number 1000. Now, a byte type won't do that because a byte can only hold whole numbers from 0 to 255. I want to hold the number 1000. So the data type I'm going to use is going to be an int that holds larger whole numbers. I'm going to call this delay time, and I'm going to set that to 1000. This equal sign means assign. So I take the value of 1000 and I assign that into my variable called delay time. Now, all I have to do is I have to delete these 1000s, write delay time, and it's just like there was a 1000 sitting right here. So if I hit start simulation, it will work just the way that it worked before. The nice thing about this is instead of, again, and right now we only have about a dozen lines or so, so it's not too bad. But when I get to longer codes, I don't want to always have to scroll through my code, try to read it and find the thing I want to change. Instead, all I have to do is I have to find the variable and say, let's change this, and change it to 300 milliseconds. And just change that one line of code will cause it to flash faster now. All right, so that is the example. Again, we're going to cover it in class. There are other videos that talk about things like data types and variables and circuits and all that. This was just to go over the example of how to do it, kind of how to set it up, how to think about it. At the end here, I have what your deliverables should look like. If this were a homework, what would you turn in? And what you would do is you would turn into me a Google Drive folder. Just like this, you'd have some type of link that you would share with me. And when I open that link, I should be able to see a couple things. And so I have this link down here that would look exactly like what you should be turning in for your homework. When we open that link, it has everything that I did for this example. So when you do a homework, everything that you did for that homework, save into your Google Drive. Everything meaning anything you do on paper. You might have one piece of paper, you might have 20 pieces of paper. It doesn't matter. Whatever you do, save it into here. You're going to take some pictures. You might have one picture, you might have a dozen pictures. That's fine. Save them all into your Google Drive folder. To make sure that the circuit's working with your code and that it's doing what it's asked and that you understand what's happening, what I'd like you to do is I'd like you to take a video. This video might be kind of on the medium size as far as how long it should be. This is a minute long. You could have them be a little bit shorter as long as I see everything that's happening. I can see them working. You can also see that I'm not expecting great video skills here. You can see I'm not even showing what's going on right here. I do have it muted. I am talking. We're just not listening to myself talk right now. And I just kind of talk through what's happening. And this is how I can see, number one, that your code works with your circuit. But number two, you explaining it a little bit makes me know that you understand what is going on. And then lastly, any code that you have. So here I have a couple codes. Let's see if I can open it up here without downloading it. Yeah, so here's one of the codes. This is my first code that I wrote, and you'll see that I don't have my variables in here. And so that was my version 1. I made a second code. And since I made 2 codes, I would upload both those codes for the homework. Everything that you do, I want uploaded. So if you have multiple codes, show multiple codes. If you have multiple videos, show multiple videos. If you have multiple pictures, multiple top-down designs, multiple whatever, save all those things so that we can see what's happening. Remember that this class is a design class, and the design is a process. Designing something is a process, and I want to see that entire process. I just don't want to see the final product. I need to see how we got from the very beginning. The very beginning was what I asked you to do right here. Set up a circuit with one LED, write a code that blinks forever, use variables. That's the starting point. I want to see how you got from there, not only what is your final product, but I want to see the process to get to that final product. And that's what I expect you to turn in for your homeworks.